Are you ready to find out how scientists are working to turn the Sahara Desert into a lush oasis and learn about the groundbreaking and ingenious idea that has captured the world's attention? Researchers have unveiled their bold plan to make the Sahara green with a single stroke of genius, which has the potential to revolutionize renewable energy and climate change. Here's how to make the Sahara Desert green again. The Sahara is the world's largest hot desert, but parts of it could be made green if massive solar and wind farms set up shop there. These farms could increase rain in the Sahara, especially in the neighboring Sahel region, a semi-arid area that lies south of the giant desert. Scientists have long known that wind and solar farms can raise local temperatures and moisture levels. Lee, who began the study as a postdoctoral researcher in the Department of Atmospheric and Oceanic Science at the University of Maryland, claims it is one of the first to model the impact of wind and solar farms on the Sahara, while also taking into account the response of growing green plants and trees to these changes. The effects of wind and solar farms covering more than 9 million square kilometers of the Sahara were modeled by Lee and his colleagues. They calculated that after a year, wind farms would produce around 3 terawatts of electricity, whereas solar farms would produce 79 terawatts. A tremendous amount of power. 1 terawatt can power about 1 billion 100-watt light bulbs simultaneously. This is certainly considerably more energy than is now needed worldwide, Lee remarked, noting that global energy demand in 2017 was only 18 terawatts. Greater nighttime warming takes place because wind turbines can enhance the vertical mixing and bring down warmer air from above. The average daily rainfall in regions with wind farms was found to rise by as much as 0.25 millimeters. According to Lee, the amount of rain that fell was double what was observed in the control experiments. Researchers found that places with wind farms had an increase in rainfall of 0.04 inches per day, which would be beneficial to the growth of vegetation in the Sahel. The Sahel would no longer be considered a desert if annual precipitation increased by as little as 8 inches and as much as 20 inches, 500 millimeters. Areas with yearly rainfall of less than 10 inches, 250 millimeters, are considered deserts. The solar farms would also have a beneficial effect on weather, according to the study authors. University of Maryland professor and study co-leader Eugenia Kalnay said, "The large-scale installation of solar and wind farms can bring more rainfall and promote vegetation growth in these regions. The rougher and darker land surfaces caused by solar panels and wind turbines are responsible for the increased rainfall. The Sahara can be converted to vegetation, although doing so will be difficult. The Sahara is the world's largest scorching desert, stretching across much of North Africa. It would take a huge effort to turn this barren land into a verdant paradise. Water scarcity, high temperatures, and other environmental factors provide formidable obstacles. One solution is to cultivate vegetation and water it with desalinated seawater brought in from the coast. Planting trees and other vegetation in the desert could be the first step in greening the Sahara. However, fresh water is scarce in the area, so it makes sense to irrigate these plants with desalinated water from the Saharan coast, which is close by. Desalination is the treatment of salty seawater to remove the salt and other contaminants so that it can be used for human consumption and agricultural irrigation. To avoid water loss due to evaporation and to supply water directly to the plant's roots, it is best to use subterranean pipes to deliver the liquid. In arid regions, water is scarce and waste prevention is of the utmost importance. The water can be piped underground so that it doesn't evaporate too much on the way there. By bypassing the leaves and stems, water can be sent straight to the plant's roots, where it can be used effectively while minimizing wasteful evaporation. Eucalyptus trees are excellent because they can withstand extreme temperatures and grow quickly. Choosing the correct plant species is crucial to the success of greening initiatives. The eucalyptus tree is offered as a viable option due to its rapid growth rate and resistance to high temperatures. They are a possible answer to the difficult Saharan climate thanks to their ability to survive in extreme conditions. Growing plants add nutrients to the soil and attract more rain to the area. As plants become established and mature, their dead leaves and other organic matter contribute to the enrichment of the soil. This procedure enhances the quality of the soil, making it more productive and able to retain water. A further positive feedback loop occurs when there is an increase in precipitation due to the presence of more plants in the area. Greening the Sahara, however, may increase the likelihood of locust plagues, which could lead to food shortages. positive outcomes for the environment and local residents may result from efforts to green the Sahara, but there is a risk that unforeseen consequences will also arise. The likelihood of locust plagues increases as conditions improve for agricultural and plant growth in the region. Crops can be destroyed by swarms of locusts, perhaps causing a food shortage in the area. The Sahara plays a significant role in carrying sand and dust particles across continents, and this has the potential to affect ecosystems worldwide, especially the Amazon rainforest. Because the sand carries moisture that contributes to heavy rain in South America, sand from the Sahara Desert is carried by dust storms over the Atlantic Ocean and may help produce rain clouds above the Amazon rainforest in South America. The water supply and ecological balance of the Amazon depend on this procedure. The natural cycle of transferring moisture to the Amazon rainforest might be interrupted if the Sahara were to become green and retain more water locally, which could have far-reaching consequences for the South American rainforest and other ecosystems. The Sahara Desert has been proposed by scientists as a site of a huge solar and wind farm to create sustainable energy. Researchers led by Yan Li and others have proposed turning the huge Sahara Desert into a renewable energy hub by installing wind turbines and solar panels throughout its wide area. The goal is to generate clean energy using the region's plentiful solar and wind resources. As a result, the Sahara could see some greenery for the first time in millennia as a result of greater rainfall and warmer temperatures. Large-scale wind farms and solar parks could have serious ecological repercussions if built in the Sahara. According to the results of the study, this could result in increased rainfall and slightly warmer temperatures, potentially helping to turn green portions of the desert that have been parched for thousands of years. The study's hypothetical solar and wind farms exceed the size of entire countries, dwarfing any currently operational renewable energy projects, and could meet 4 times the world's energy needs. The researchers used models of large-scale solar and wind farms, roughly 38 times the size of the UK, to evaluate the possible impact. The massive magnitude of this plan is highlighted by the fact that these megafarms could produce as much energy as the entire world currently consumes. Warmer air is drawn to the ground by wind farms, raising temperatures, while solar panels soak up more sunlight, warming the ground itself. The study elucidates the mechanisms at play in the observed temperature shifts. Turbine blades in wind farms can enhance local temperatures by forcing hot air to the ground below. However, solar panels actually cause global warming because of the solar radiation they absorb. The low pressure caused by the wind turbines increases precipitation and vegetation growth in the Sahara. The presence of wind turbines causes a decrease in atmospheric pressure due to the disruption of air movement. The surrounding wind gathers speed as it approaches the turbines, then climbs and cools, causing water vapor to condense and produce rain. This more frequent precipitation might help plants flourish. The influence on local economies, political ramifications, and the unknown impact on desertification all pose obstacles to the successful implementation of such a scheme. The idea of turning the Sahara into a green energy powerhouse is fascinating, but doing so will be no easy feat. Communities exist in the Sahara and the Sahel regions, and the land is crucial to their survival. The initiative would call for serious thought about its potential effects on society and the economy. Energy security and international cooperation are also crucial to the success of such a big undertaking. It is also unclear what effect climate change and changes in land usage will have on the desertification over time. To guarantee a long-term energy transition, it is crucial to take these findings into account alongside other factors. The research highlights the need to think about the bigger picture when planning renewable energy initiatives on a wide scale. In spite of the fact that progressing to environmentally friendly power sources is basic in the battle against environmental change, the positive and adverse consequences should be painstakingly assessed and considered into the general energy change procedure. To accomplish an effective and reasonable change to efficient power energy sources, it is vital to figure out some kind of harmony between natural repercussions and social, financial, and specialized viewpoints. Thanks for watching. Please hit that like button and subscribe to our channel if you want to watch more videos like this.